The momentum and energy for a physical object are actually two sides of a more general four-dimensional entity known as momentum energy, or Momenergy. Momenergy is something that exists independently of any reference frame or observer. It has a reality all its own, which makes it more real than what we can observe as momentum and energy separately. The momenergy of an object is just its mass moving in a direction in four-dimensional spacetime. Momenergy has three components directed in space and one component directed in time. It is difficult to properly visualize a four-dimensional object, but we can look at it in a simplified version if we assume the momenergy component of one dimension of space is 0. In this case, we have two dimensions of space in the horizontal plane with one dimension of time pointing upward. Momenergy has a magnitude, its length, which is the mass of the object. Additionally, momenergy has a direction, which is its orientation in space-time. The direction is always pointed along the world line of the object, which is its path through four-dimensional space-time. When we view momenergy from the perspective of an observer in their frame of reference, then the space components of momenergy appear as momentum, p. The momentum of each component of space along the x and y axes are px and py, respectively. The time component of momenergy appears as energy, E. Recall that the magnitude of momenergy is the mass of the object. In our world, which is in four-dimensional Lorentzian spacetime, there is one elegant relationship that links the mass, momentum, and energy of an object. This relationship is the mass squared is equal to the energy squared minus the momentum squared. Notice that mass is constant, so if the momentum of an object goes up, that means the energy of the object must also go up to ensure that the same value is held for mass. If momentum goes down, that means that the energy of the particle must also go down. Something interesting happens when momentum is 0, which is what happens if the object is at rest. Notice that energy does not go to 0. In fact, energy in this case equals the mass. What does that mean? It means that there is energy associated with the existence of the mass itself, regardless of its motion.